Welcome to another set of solutions for your holiday maths homework. We're going to start off with a bit of integration here. So we've got a curve with this equation, and they tell us that the curve with the equation y equals f of x passes through the point 1, 6. And then they give us the derivative of the curve, the gradient function, and tell us to find f of x. So the first thing we've got to do is we've got to go from the derivative back to the curve, so we're going to integrate. So f dash of x is equal to 3 plus 5x squared plus 2 times x to the minus a half. And that's changing it from fraction form, which we've got here, into index form. And now I'm going to multiply the brackets out. And I'm writing at each stage what it is I've got, and I haven't integrated yet, I've still got the derivative. So we've got 5 times x to the 3 over 2 plus 2 times x to the minus a half. So that is that's in the right form for integrating. Now we've got separate terms, so now f of x, which is what we're after, is equal to the integral of that lot. 3 plus 5 x to the 3 over 2 plus 2 to x to the minus 1 half with respect to x. So now I'm actually going to do the integration. So I've got 3 times x to the power of 1 divided by 1 plus 5 times x to the power of 5 over 2, because I've added 1 to it, divided by 5 over 2 plus 2 times x to the half divided by a half plus c. Don't forget the plus c. And now we're going to simplify that. So we've got 3x plus 2x to the 5 over 2 plus 4x to the half plus c. And that's our first step done, really. Now, in order to find f of x, of course, we need to know what the constant is, and of course we haven't used the point yet, so that's how we're going to find it. So we are going to now find c by substituting that point. And it was 1, 6, I believe, 1, 6. So x is obviously equal to 1 and y equals 6. So we've got 6 equals 3 times 1 plus 2 times 1 to the 5 over 2 plus 4 times 1 to the half plus c, which simplifies to 6, 3 plus 2 plus 4 plus c. So 6 equals 9 plus c. So c must be equal to -3. So we can finish off now by saying that f of x is equal to 3x plus 2x to the 5 over 2 plus 4x to the half minus 3. And you can have that warm, fuzzy feeling of having got it right. Things you might do to check, well, you might substitute 1, 6 in there just to check it's on the line, and possibly you might even differentiate it to check you did it right. So, the C2 question. the turning points of a curve. So we're given the equation of a curve, and we're asked to find dy by dx. So this is nice, sort of 2-mark starter. They've pretty much put it in the right form for differentiating. So it's 6x squared minus 10x minus 4. And that gets you 2 marks, so pretty straightforward. Just make sure you remember differentiating it goes down, integrating it goes up. Now, using the result from part A, find the coordinates of the turning points of C. So the first thing we're going to do is just remember that at turning points dy by dx equals 0. So 6x squared minus 10x minus 4 equals 0. And I'm going to solve the quadratic by trying to factorise it. So I'm going to divide through by 2 first, just to make my life a little bit easier. So we've got minus 5x minus 2. And that just makes it easier to factorise. It's one of those things, if you can spot it, it speeds it up. So we've got to have 3x there and an x there. And then we've got to have, I believe, a 1 here and a 2 here. And it's going to be a plus 1 and a minus 2. So x is either going to be a negative third, or x is going to be 2. So we need to find the coordinates. So we've just found the x part of the coordinate, and now we're going to use the original equation to find the y part. So if x equals a negative third, then y equals 2 times a negative third cubed minus 5 times a negative third squared minus 4 times a negative third plus 2. And if you pop that into your calculator, it's called 2, you can do that of course, you get 73 over 27. And now for the other one. If x is equal to 2, then y is equal to 2 times 2 to the power of 3 minus 5 times 2 to the power of 2 minus 4 times 2 plus 2. And again, you stick that lot in and it should turn out to be negative 10. So we've got 2 turning points. We've got one that's at minus a third 73/27, and we've also got one that's at 2 minus 10, and that got us 4 marks. Now d2y by dx squared, well, we just, from our result above, we differentiate it and we get 12x minus 10. If you're not sure where that came from, let me just go back up and show you. So I've just taken dy by dx and I've just said d2y by dx squared is equal to 12x minus 10. So that's 2 marks. It's trivial, isn't it? Hence or other determine the nature of the turning points. Okay, so we found the second derivative, so we just need to consider both of our points. So when x is a negative third, d2y by dx squared is equal to 12 times a negative third minus 10, and 12 times a negative third is negative 4 minus 10, which is minus 14, and we're not really interested in a number. What we are interested in is the fact that it's less than 0, which means that the gradient is decreasing, which means it's a maxima. And the other case, when x equals 2, d2y by dx squared is equal to 12 times 2 minus 10, which is 14, and that's greater than 0, which means the gradient is increasing, which means that it's a minima. And they give us 2 marks for the pleasure. Hope that was useful. and have a go at the next one when I send it to you. Now I'm just going to figure out how to stop this recorder. There we are, stop.